Hello to everyone. I am Professor Raja, working as Assistant Professor EC Department, SNS College of Technology, an autonomous institution, Coimbatore. In this YouTube video, I am going to discuss about the 19 ECEB 301 Analog and Digital Communication subject under the Unit 4 Digital Modulation Techniques for the topic Bandwidth Efficiency. Based on my previous YouTube video, you may have some knowledge about what is modulation, what is the difference between analog modulation and digital modulation, the various classifications of analog modulation, that is amplitude modulation, phase modulation and frequency modulation, and the various classifications of digital modulation like amplitude shift keying, phase shift keying and frequency shift keying, and the combination of ASK, PSK called QAM, both are combined together. Now I am going to discuss the topic called bandwidth efficiency. So in general, the three factors that influence the choice of digital modulation system are: the first one is the bandwidth efficiency, second one is error performance, third one is equipment complexity. Bandwidth efficiency, the number of bits per second that can be transmitted per hertz of channel bandwidth is called bandwidth efficiency. The probability of making a bit error at the receiver as a function of signal to noise ratio is called the error performance. A parameter which effectively corresponds to the cost of the system, which makes more complex or less complex of the equipment, is called equipment complexity. In general, bandwidth efficiency or spectral efficiency or spectrum efficiency refers to the information rate that can be transmitted over a given bandwidth in a specific communication system. It is a measure of how efficiently a limited frequency spectrum is utilized by the communication system. Bandwidth efficiency describes how efficiently the allocated bandwidth is utilized or the ability of modulation scheme to accommodate data within a limited bandwidth. The below table shows the theoretical bandwidth efficiency limits for the main modulation types. The spectral efficiency of a modulation scheme with the transmission rate R and bandwidth B is defined as rho is equal to R by B, that is the transmission bit rate to the minimum bandwidth in hertz. It also represented as percentage of rho is equal to R by B in percentage. Bandwidth efficiency is generally normalized to a 1 kHz or 1 Hz bandwidth, and that it indicates the number of bits that can be transmitted through a medium for every 1 Hz. Usually bandwidth efficiency is represented as a percentage of efficiency. So in this YouTube video, I discussed what is the main use of bandwidth efficiency. In general, for a band of some data, how much data is needed for a particular bandwidth, that can be divided by a bandwidth efficiency. If you understand easily, for a classroom which having the capacity of 60 chairs, if the class students total strength is 60, means the efficiency is 100%. If the class student strength is 30, means the efficiency is 50%. So as you are an engineer, before you are transmitting to a signal, you must aware of how much data bitrate can be transmitted to a how much number of bandwidth. For example, if you are sending a data in 4G, which is less data rate compared to 5G, because when compared to 4G, 5G will become a higher bandwidth and also they have a faster data rate. If you are a RF engineer, your idea is to be increase the bitrate, whereas you can minimize the bandwidth. So whenever the bitrate should be very small, then the bandwidth will be high, or vice versa. In general, the spectral efficiency of a modulation scheme is calculated as the ratio of transmission bitrate to the minimum bandwidth. In general, transmission bitrate is represented as a bits per second, and a minimum bandwidth, that is bandwidth, is represented as in hertz. You know very well how to calculate bandwidth. Bandwidth is difference between highest frequency to the lowest frequency. So this YouTube video, I discussed what is meant by a modulation, that is a process of adding message with the carrier. Then why we go for digital modulation. Then the three important parameters in digital modulation techniques are: first one is the bandwidth, second one is the error performance, third one is the equipment complexity. So whenever the bandwidth efficiency is high, we can transmit the data in 100% without noise. Then error performance, as you are an engineer, as much as possible of reduction in signal to noise ratio, this will increase the performance of system. Third one, equipment complexity. So whenever the equipment will be simple, then the user have a satisfaction to use that equipment in a longer period of time. So next YouTube video I am going to discuss with a new topic. Thank you for watching my video.